Welcome back to my YouTube channel. So in this video we're going to be talking about oxidation number. So why should we learn oxidation number? We will learn oxidation number, or oxidation number is very important in naming compound. You cannot name compound without its oxidation number. So oxidation number is very necessary. So let's do some oxidation number. But before we do about oxidation number, before we solve problem based on oxidation number, you must know the first 20 elements and the group they belongs to. So how to know the group they belongs to? So this is the periodic table. So how can we use this periodic table, and how this periodic table relates to oxidation number? So in the periodic table we have groups and we have period. So discs like this are called period. Why these are called period and these are called group? So elements here belongs to group 1, group 2, group 3, group 4, 5, 6, 7 and 8 or 0, or you call this the number gas because they are stable. So hydrogen belongs to group 1. And how can we know elements that belongs to groups? And how without using the oxidation number, how will you know whether this element belongs to group 3 or group 4, or maybe you have crammed it but you cannot remember? So let's go back to our first 20 elements. Let's go back to our shares. So we have KLMN share. We have the first share, the second share and the third share. I also have the fourth share. So these shares, you have the K, ML and shares. So the K share can contain only 2 electrons. So if these 2 electrons is complete, it will be classified on the noble gas structure. As you can see here, we have hydrogen. Hydrogen only has 1 electron. That is why it is classified in group 1. This is the valence electron of hydrogen, so that is why it is classified as group 1 elements. But let's talk about beryllium. As you can see here, beryllium is in group 2. So let's write beryllium. Here is beryllium 1, beryllium 2. So 1, 2, 3 and 4. You see that this share, the K share, is completely filled with electron. So you have the AMNL share. So as you can see in beryllium, the beryllium have 4 electrons, and this K share can only contain 2, and it has been completely filled up. So this L share can contain 8 electrons, so it has 2, so remaining 6. So this remaining 6, so we call these 2 electrons the valence electron, because these are electrons that is in the atmosphere of these elements. This is the atmosphere of these elements. The L share is the atmosphere of these elements, because this is the highest energy level of these elements. So that is why it's classified in group 2. So if you're talking about helium, helium only has 2 electrons. So these 2 electrons completely filled up the K share. As you can see here, it's completely filled up the K share. So it will not go into reaction because it is filled up. It doesn't need to lose or gain electron. So group 1, group 2, group 3 are generally metals, and they are very reactive. They give out electron while the non-metals receive the electron. So I think I've laid a basic understanding about this periodic table. As you can see here, sodium, if you count sodium, you have that sodium is 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Sodium here is 11. So if we decide to place this electron, let's count sodium 1, sodium 2, 3, 4, 5, 6, 7, 8, 9, 10. So sodium remain 1, which is this. 11. So it has only one valence electron, as you can see here, in its atmos share. So that is why it is classified in group 1. If any element should have 3, as you can see in aluminium has 3 in its atmosphere, so that is why we're going to classify it as group 3 elements. So let's go over to our main business. So let's find the oxidation number. Why are we looking for oxidation number? Oxidation number is very necessary for naming of compound. As you can see here, this is potassium triazochlorate. We don't know what next to pronounce, so for us to pronounce this compound accurately well, what we have to do first is to calculate the oxidation number or find the oxidation number. So let's go back here. As you can see here, oxidation number of potassium is 1. Oxidation number of oxygen is -2. So let me show you how to do this oxidation number. So here is +1, here is +2, here is +3, here is they can receive and they can lose. We are going to treat this group 4 separately. So let's go over to group 5. So this group 5, we're going to write -3. Reason, they have to gain 3 electrons to obtain this noble structure. They have to gain 3 electrons. So oxygen, so elements in group 6 are -2. They have oxidation number of -2, while elements in group 7 has oxidation number of -1, because they have to just gain 1 for them to have this noble structure. So why are you putting +1, +2, +3, -3, -2, and -1? As you can see here, in electron, for electron to be electrically neutral, which means the total number of proton is equal to the total number of electron, so which makes them electrically neutral. Electron are negatively charged while proton are positively charged. So for an element, for example sodium, to be electrically neutral, which means the total number of proton is equal to the total number of electron. So for this sodium to have +1, as you can see, for this sodium now to have +1, which means that the total number of proton is 1 greater than the total number of electron. For this to have 1, which means it have lose 1 electron, so the proton charge, the positive charge, will now overcome the negative charge. So this is how this work. As you can see in oxygen is 6, so it needs 2 electrons to become to obtain the noble structure. So oxygen has to go into reaction and gain 2. So this oxygen gaining 2 means that remember that electron is negatively charged while proton is positively charged. So for this thing to gain 2, which means that the total number of electron is not greater than the total number of proton. So for us to find the oxidation number of oxygen, as you can see here, oxidation number of oxygen is -2, because the total number of electron is not greater than the total number of proton. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what was oxygen here? Oxygen here was 8. Oxygen here was 8, which means it has 8 proton and 8 electron. So oxygen we go and gain more electron, having -10 electron and 8 proton. So -10 plus 8 will now give us -2, which means oxygen has more -2 electron. It has gained more 2 electrons, so this charge will now come out to -2. So this is how this oxidation number work. So let's find the oxidation number of this. Let's go back to our periodic table. Potassium is 1. So what is chlorine? So here chlorine is what? -1. What is oxygen? Oxygen is -2, but times 3. So let's find. Well, we're not going to find for chlorine. Why are we not looking for chlorine? Because chlorine is what we are looking for. So to calculate the oxidation number here, potassium is +1 plus chlorine as what we are looking for, plus oxygen. oxygen is minus 2 times 3, which is equals to 6, which this is equals to 0. If there is no charge, which means this compound is equals to 0. But if there is charge, which means this compound is equals to that charge. Let me say here is plus 1, which means in finding the oxidation number here, when we are done calculating for this side, we are going to equate it to plus 1, because here was plus 1. So finding the oxidation number here, we have plus 1 plus chlorine plus minus 6. So chlorine will now become, take this to the right hand, we now have plus 6, and take this to the right hand side, we now have minus 1. So here chlorine will now become plus 5. So but here chlorine was minus 1. Why? To tell you that we don't have a stable oxidation number. There are few elements which have stable oxidation number, but in some cases they change, so depending on the compound. So oxidation number generally depends on the compound they are presenting, the number, whether they lose or gain electron. So here now we now have chlorine as plus 5. So to name this compound, we're going to say potassium trioxo. Why here is tri is because there is presence of 3 oxygen. If 4 was here, we're going to say tetra. If 5 was here, we're going to say penta. If 6 was here, we're going to say hexa. If 7 was there, we're going to say hepta. If 10 was there, we're going to say deca. If 9, none. Or if 8, octa. So here now we now have potassium, we have chlorate, and we have oxygen. So to name this, we have to say potassium trioxo, because oxygen is here, trioxo, chlorate. Any in the middle number, we are going to remove that the last 3 words and add ate. Why the last number? We are going to remove last number and add oxo for oxygen. Let's name more. We are going to understand how this thing is working. So in pronouncing this compound, we are going to pronounce this as potassium triosochlorate 5. So let's find the oxidation number of this. So this is calcium hydroxide. So to calculate the oxidation number of calcium and calcium hydroxide, so you remember here is multiplying by 2. So to find oxidation number of calcium in calcium hydroxide, we have oxygen to be minus 2 times 2. Why? Because here is multiplying this oxygen by 2, and the oxidation number of oxygen is minus 2, plus hydrogen is plus 1 times 1, which is now 2, which is equals to 0. So here is calcium, here is plus 2 crossing over, we have equals to minus 2, and minus 4 crossing over, we now have plus 4. So here when I become calcium is equals to minus 2 plus 4, we now have plus 2. So the oxidation number of calcium here is plus 2. So here is calcium hydroxide. So let's do for potassium permanganate. So this potassium permanganate or potassium tetraoxo manganate. What? We don't know the oxidation number, so we can't pronounce it until we have to know the oxidation number. So what is potassium there? Manganate. You pronounce it as manganate instead of manganese. Remember, if you're looking at the oxidation number for the metal compound, for the elements in the metal compound, we remove that last 3 words and add ate, manganate. If carbon was there, we're going to pronounce it as carbonate. If chlorine was there, we're going to pronounce it as chlorate. So here now we now have potassium tetraoxo manganate. What? So potassium here is plus 1. Remember the charge here is 0. So here will now be 0. We are going to equate this compound to be equals to 0. So manganate, as what we are looking for, will become X, or we can also add manganate there, plus oxygen is minus 2 times 4, because this 4 is multiplying this oxidation number of oxygen. So we now have minus 8. So minus 8 crossing over, we now have X is now equals to 1 crossing over, you have minus 1, and minus 8 crossing over, we now have plus 8. So here will now become equals to plus 7. So in naming this compound, you have to now say potassium tetra, because why? 4 was here, tetraoxo manganate 7, potassium tetraoxo manganate 7. So in this kind of question, if I want to confuse them more, I will just do some I'll write something like this. This question maybe I wanna change it to be like this, -1. So don't get confused if you see this kind of thing. Just equate it to -1. Why? Because here is raised to the power -1, and find for the oxidation number here. Here is manganese plus oxygen is -8. So here is manganese -8 crossing over, we now have what? 8 -1, we now have +7. So the oxidation number here is equal to the oxidation number here, because potassium is 1, and we equate this then to raise to the power -1. So let's practice. I think this should be the last question. So let's practice this one. And how can we pronounce this? So we are asked to find the oxidation number of copper here, which generally we know that oxidation number of oxygen is -2. So -2, this is copper, plus in brackets -2 is equals to 0. So copper plus times minus is -2, which is equals to 0. So copper is now equals to +2. So in some cases we can also see copper as equals to +1, but for here we have that copper is equals to +2. So how can we name this? So naming this, we're going to say copper 2 oxide, but there is no 2 here. So why are we pronouncing this then as 2? We are pronouncing this then as 2 because the oxidation number here is +2. In some cases, if this then was sodium chloride, as you can see, we're not going to say sodium 1 chloride. There's nothing like that, because sodium has a fixed oxidation number. So why pronounce this then? We're going to just say sodium chloride. This is a salt. So I hope you grab and understand something from this lesson. Thank you and goodbye. Don't forget to like, subscribe, and hit the notification bell for more videos like this on Sagashos.